Hi everyone. This is the last part of vector algebra. In this last part, I will explain what is vector triple product and how to apply this vector triple product to solve JEE main questions or JEE advanced questions. Vector triple product means we will take cross product of another vector. Well, if A bar, B bar, C bar be three vectors, then A cross B cross C is called vector triple product. Here A cross B cross C. We have a 2 cross. This is known as a vector because the output is vector and we are using 3 vectors. So that's why it is called vector triple product. Well, now how do we define this vector triple product? A bar cross B bar, A bar cross B bar, cross C bar. Okay. How to take? You see that first you take the dot product of longest. These are the farthest one. Take the dot product of farthest. That is A dot C. Here you see. Into B bar vector. And next nearest. B dot C. B dot C into A bar. So remember that first you have to take A dot C. This is 1. Minus next you take B dot C. This is 2. All right. Okay. So now how to prove that this vector represented in the plane of only B bar and A bar. See, this is lies in the plane of B bar and A bar. Any vector in the plane of A bar, B bar can be written as R bar equal to XA bar plus YB bar. Any vector in the plane of A bar, B bar can be expressed as linear combination of A bar and B bar, that is XA bar plus YB bar. Okay, well, so let us analyze what is meant by A cross B and cross C. What is meant by A cross B and cross C? See here that A bar cross B bar is perpendicular to A bar and B bar vector, right? It comes out of the plane of A bar and B bar. Well, so let us say this is A bar vector and this is B bar vector and this is A bar cross B bar vector. Well, like this. This is the A bar B bar vector. A bar cross B bar. Well, now what is meant by A bar cross B bar cross C bar? Well, see here that A bar cross B bar cross C bar. Okay. It is perpendicular to A bar cross B bar, comma C bar. Right? Now you observe that A bar cross B bar, all right, is perpendicular to A bar cross B bar cross C bar is perpendicular to A cross B, isn't it? All right. Then where to draw that A cross B cross C? Where to draw that A cross B cross C? When this is a vector A bar cross B bar and this is the plane, then where to draw A cross B cross C? It must lie on the plane of A bar and B bar. It must lie on the plane of A bar and B bar. Right. So now let us denote that this is A bar cross B bar cross C bar vector. All right. This is a perpendicular. So it should lie in the plane of A bar B bar vector. It should lie in the plane of A bar B bar vector. Okay. So the meaning of this statement is this is possible. This is possible. A cross B cross C Okay, lies in the plane of, A bar and B bar. A bar and B bar. So you can have just a small trick that wherever bracket is there, here A bar cross B bar, we have a bracket. Therefore, this vector lies in the plane of A bar B bar. This vector lies in the plane of A bar and B bar. If bracket is there for B bar and C bar, then it will lie in the plane of B bar and C bar. So any vector in the plane of A bar and B bar can be written as linear combination of those vectors. So therefore, this implies I can write that A bar cross B bar, okay, cross C bar. It lies in the plane of A bar B bar, so that I can write XA bar plus YB bar. Isn't it? Well, now we need to find out X and Y. We need to find out X and Y. Taking dot on both sides, taking dot C on both sides. Right, well, taking dot C on both sides. We take dot C bar on both sides. Well, what will you get? We get that. Anyway, you see, A cross B cross C is perpendicular to A bar cross B bar and C bar. So on taking dot C, you will get LHS is equal to 0. Because A cross B cross C is perpendicular to C bar. So dot product is 0. Whereas on RHS, X into A dot C, well, plus Y into B bar cross B bar dot C bar. Good. Okay. All right. So now we got some X and Y values here. You see that? You just rearrange that X into A dot C equal to minus Y into B dot C. Implies I will write a ratio that X by B dot C, equal to Y by minus A dot C. Isn't it? Right? So you take just this is equal to T. This ratio equal to T. Then you will have that X equal to, on cross multiplication, we will get that B bar dot C bar into T, as well as Y is equal to minus of A bar dot C bar into T. Substituting back these values in that X A bar plus Y B bar. Well, okay. So therefore, A cross B cross C equal to, okay, you will have that X equal to B bar dot C bar into T. So I'll take T as a common. Then you will have that B bar dot C bar into A bar minus A bar dot C bar into B bar. Well, now to find out the value of T, I will choose some particular vectors. Right. Suppose you take that A bar is equal to, suppose that A bar is equal to, you take I cap, and B bar is equal to, you take J cap, and C bar is equal to, you take that I plus K. Well, what is A bar cross B bar? That you will get K, right? So A bar cross B bar is K cap, and taking cross with I plus K. Then you will get J cap on left side. Well, This is equal to T into that B bar dot C bar, B bar dot C bar is nothing but 0 minus A bar dot C bar, A bar dot C bar is nothing but 1 into B bar is nothing but J. So this implies you will get T equal to minus 1. Hence we proved that substituting that T equal to minus 1 here, you will have the result. Right? So therefore, A bar cross B bar cross C bar is a vector in the plane of A bar, B bar and perpendicular to C bar. Remember, whenever this kind of context comes, a sentence comes, you must immediately able to identify what it does actually mean. So what is meant by A bar cross B bar cross C bar is a vector in the plane of A bar B bar and perpendicular to C bar. Remember, C bar need not lie in the plane of A bar B bar. Well, here I'll write that suppose for example P bar cross Q bar cross R bar. This is equal to how to express this. Okay, remember you have to take that dot product of path test. You have to take dot product of path test. So P bar dot R bar into Q bar minus now nearest. This is nearest minus P bar dot Q bar into R bar. If you can remember of a triple product formula, you can do wonder. Well, here you see that how to do that A bar cross B bar cross C. So this vector should lie in the plane of B and C. It should lie in the plane of B and C. Wherever bracket is there in triple product, that vector will lie in the plane of those vectors. So you write that A dot C. Listen carefully. A dot C into B bar and A dot B into C bar. Well, now I will do a few questions based on this fact. Based on this fact. Well, so you see A bar, B bar, C bar be three vectors, out of which B bar and C bar are non-parallel vectors. Alpha and beta are the angles which A bar makes with B bar and C bar respectively. A cross B cross C equal to half A bar. Then what is modulus of alpha minus beta? This is of a previous JEE mains question. Well, question is quite simple and very straightforward question. Just you have to use the definition. Okay. I'll use the definition. First, I'll take that path test, dot product of path test. So A bar dot C bar into B bar minus A bar dot B bar, A bar dot B bar into C bar. This vector lies in the plane of B bar and C bar. This is equal to half into B bar vector. And there is no C bar, so you write minus 0 into C bar vector. All right. You just equate the scalar components. You just equate the scalar components. On equating the scalar components, A bar dot C bar is equal to, we get half, right? And A bar dot B bar is equal to 0. Good, good. Here A bar, B bar, C bar are unit vectors. They are unit vectors. So I can write here, you see that mod A, mod C, mod A is 1, mod C is 1, and angle between that is alpha. That's equal to 1 by 2. And angle between A bar comma B bar is equal to 90 degrees. Right. Okay. This is equal to alpha. Angle between A bar, B bar is alpha. So I'll write here beta. Good. So therefore, we will get that beta is equal to 60 degrees. Pi by. We got it. We got it. So alpha is pi by 2 and beta is pi by 3. Therefore, modulus of alpha minus beta is equal to 30 degrees. Quite simple question asked in JEE Main based on the fact that A bar cross B bar cross C bar, triple product of vectors. Now here is one more question, the way we use the triple product, right? Here it is a little bit different. That A bar, B bar, C bar be non-zero vectors such that no two of them are collinear. No two of them are collinear, right? Otherwise, you will get zero. Otherwise, you will get zero. Okay. So A cross B is equal to 1 by 3 mod B bar mod C bar into A bar. We, without hesitating, we will apply that same formula here too. Right. We'll apply first A bar dot C bar. Well, A bar dot C bar, okay, into B bar vector minus B bar dot C bar. Remember, B bar dot C bar into A bar equal to 1 by 3 mod B bar into mod C bar into A bar vector, and there is no B bar vector on RHS. You just equate on either side. You just equate from either side. You will get that A bar dot C bar is equal to 0. Because on RHS there is no B bar vector. And minus of B bar dot C bar is equal to 1 by 3 into mod B bar into mod C bar. Now we will apply dot product of two vectors. This is minus of mod B bar, mod C bar. Okay. Angle between them is theta. So therefore cos theta equal to 1 by 3 into modulus of B bar into modulus of C bar. Well, so you can cancel mod B bar, mod C bar so that you will get cos theta is equal to minus 1 by 3. Nothing but theta is an obtuse angle. And they are asking to find out what is sine theta. Right, sine theta is equal to root over 1 minus cos square theta. So root over 1 minus 9, 1 by 9. That's equal to 2 root 2 by 3. Good. Here is one more example, okay, of previous JMate 2021. It is a nice question. It is a nice question as there are many brackets in this vector. You see, it's looking very clumsy and very difficult. You see, so many cross products are there, so many cross products. But if you think wisely on applying that triple product of vectors, it is so simple. Okay, we will simplify that from innermost expression, from innermost expression. So that innermost expression is this one, like this. Okay, you see, not like that. I'll say this is the innermost expression. This one. Okay, I'll write for to have a bigger clarity. I'll write that A bar plus B bar. Okay, all right. Cross. This is. I'll apply the triple product. I'll apply the triple product here. Here I'll apply the triple product. Okay. So first I'll take the farthest one, that is A dot B. A dot B. Well, A dot B into A bar minus. Okay. Just a moment. Instead of doing that, there is another innermost. I'll do that. Solve. Well, first I'll finish this innermost bracket. This one. Okay, this simplifies to A bar cross B bar. A bar cross B bar minus B bar cross B bar. So that B bar cross B bar vector becomes 0. Well, so given vector product is equal to, now I will write that A bar plus B bar, okay, cross, we have on left side two brackets. So A bar cross, this is A bar cross B bar, bracket close and another bracket close, and this is cross B bar vector, okay, and again bracket close, this bracket closed, okay, all right. So this is equal to, now we have to apply a triple product here. We have to apply a triple product here. You take that this is A dot B, right? So this is equal to A bar plus B bar cross, okay? This is A dot B, into A bar vector, minus A dot A into B bar vector, Next nearest one. Okay. All right. This is cross B bar vector. Good. This is cross B bar vector. I'm closing the bracket. So this is equal to, now you see what is the A bar dot B bar. A bar dot B bar value is equal to, you see that 1 into minus 1, and this is 1 into 2, and this is 2 into 3. 6 plus 2, 8, 8 minus 1, it is 7. So A bar dot B bar is equal to 7. And what is magnitude of A bar? Magnitude of A bar is equal to root 6. So I'll apply that. A bar plus B bar. Okay. Cross, right? A bar dot B bar is 7. So it is 7 A bar. And minus 6 B bar. And you need to apply that cross B bar. All right. This is cross B bar vector. Good. Like this. So this is equal to A bar plus B bar. You must be very careful in simplifying the expressions. Now you see this is A cross B, and anyway B cross B is 0. So this is nothing but 7 into A bar cross B bar. Well, okay. So this further is equal to, you can bring out 7. Okay. Here you see that A bar cross, you can write 7 outside, A bar cross A cross B. Well, plus 7 into B bar cross A cross B. There are two ways. Either you can simplify these expressions, or you can find that A bar cross B bar and A plus B and again cross product. You find A plus B, you find A cross B, and again for them, you need to find out cross product of those vectors. Well, or otherwise, you have to keep on simplify those expressions. 7 into A dot B. A dot B is nothing but 7. A bar. Minus A dot A is nothing but 6. B bar. All right. Okay. Next here you see B dot B. So what is mod B vector? Mod B vector is 9 plus 1, 14. Okay. Mod B bar is equal to root 14. So here I am writing plus, I have taken 7 out. This B bar dot B bar is nothing but 14. So it is a 14 A bar. Minus A bar dot B bar is nothing but 7 into B bar vector. I hope you got it that this is equal to 7 into. Okay. 21 A bar vector minus 13 B bar vector. Now it is so simple. Okay, I have just simplified the entire expression and substituting A bar and B bar vector, you will get the answer 7 into 34i minus 5j plus 3k. Here is a question relating to that scalar triple product and vector triple product. It is also very nice question. Okay. Now we have to simplify that each expression. Remember, assume this is alpha bar vector and this is beta bar vector and this is gamma bar vector. Okay. So let us simplify that. What is alpha bar vector? Alpha bar vector is equal to A bar dot C bar. Okay. A bar dot C bar is nothing but 3. Okay. I will write beginning in the beginning. Okay. A bar cross B bar cross C bar. Okay. This is equal to, first you have to take that A bar dot C bar is nothing but 3 into B bar minus A bar dot B bar is nothing but 1 into B bar vector. 1 into this is C bar vector. Similarly, beta is equal to C. B bar dot A bar. B bar dot A bar is 1. So 1 into C bar minus B bar dot C bar is nothing but 2. That is 2A bar. And gamma bar equal to C bar dot A bar nothing but 3B bar minus C bar dot B bar is nothing but 2A bar. All right. We are asking that box of this one. So what is box of alpha, beta, gamma? So this box of alpha bar, beta bar, gamma bar equal to, I'll write that this is nothing but box of 3B bar minus C bar, okay, minus 2A bar plus C bar, okay, and minus 2A bar plus 3B bar. You please try to remember that scalar triple product, what is the box of linear combination of vectors? Box of linear combination of vectors. This is a determinant of, there is no A bar component, 0, 3, minus 1, minus 2, second vector, and 0, and 1, and minus 2, this is 3, and this is 0, into box of ABC. This is box of A bar, B bar, C bar. Well, let us expand the determinant that this is 0, first one, minus 3 into plus 2, that is minus 6. And this is minus 6 into minus 1 plus 6. Oh, nice. Into box of A bar, B bar, C bar. We got this value is equal to 0. Now I'm going to derive a few standard formulas. Well, now you see, there is one important deduction from using this vector triple product. What is A bar cross B bar dot C bar cross D bar? This is the dot product of two cross products. Dot product of two cross products. A cross B dot C cross D equal to, you take that A dot C and B dot C. You start with A cross B. Okay, here A dot C and B dot C. Determinant of. Again, B dot C and B dot D. Here you see. A dot C, B dot C, A dot D, B dot D. We have taken each and every combination of dot product. Well, okay, A dot C, B dot C. How to do that? How to do that? Very simple, very, very simple. Assume that this is equal to E bar vector. Assume this is some E bar vector, isn't it? So that LHS is equal to box of A bar, B bar, and E bar vector. So that I can write this is A bar cross B bar cross E bar vector. So therefore, this I can write A bar cross B bar cross C cross D. Isn't it? Now putting bracket here. Now apply triple product that A bar. Sorry, 1 minute, please. Excuse me. This is a dot product. This is box. So this is dot. So A bar dot, A bar dot. You see, apply the triple product. Remember that this is B bar dot D bar into C bar minus B bar dot C bar into D bar. It lies in the plane of C and D. Now taking the dot product. Now taking the dot product, you will get the answer. This implies A dot C bar into B bar dot D bar, isn't it? Minus B bar dot C bar into A bar dot D bar. This is over. Excellent. The proof is very, very good. Okay. Well, here is a question based on that particular concept. Okay, asked in previous JEE mains. A bar, B bar, C bar be three coplanar concurrent vectors such that angle between any two of them is same. Angle between any two of them is same. If the product of their magnitudes is 14, product of their magnitudes is 14. Well, okay. Okay. Next, what is A cross B dot B cross C given that plus something 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 equal to 168. Asking what is mod A plus mod B plus mod C. Well, so this question is just an application of aforesaid, not theorem, as a result. As a result. Okay. So we'll do one by one. First, we assume that mod A bar is equal to some P or A and mod B bar is equal to B and mod C bar is equal to C. Well, now we will apply the determinant for each one. For this, we will apply that determinant of, okay, with A, you take dot. That is A bar dot B bar and A bar dot C bar. This is over. Now with B, B bar dot B bar, B bar dot C bar. Well, okay, this is over. Plus second determinant. Here you see, with B, you take dot C dot A. B bar dot C bar, B bar dot C bar, B bar dot A bar. And with C, C bar dot C bar, C bar dot A bar. Good. All right. Plus the last one. You take that with C dot A dot B. C dot A, C dot B, okay, A dot A and A dot B. All right. Angle between any two vectors is same. Angle between any two vectors is same. This is equal to 168. I thought question was so simple. It is the application of the aforesaid result. I thought that is not the case. Okay, it is taking too much time to solve this question. So let us have idea of solving this question. It is very difficult to get the idea. In this way, we will be trapped. Okay. See here that A bar, B bar, C bar are three coplanar vectors, right? They are three coplanar vectors. They are all lying on the same plane, isn't it? So therefore, A bar, B bar, C bar are three coplanar vectors, are coplanar. All right. So therefore, what is the vector perpendicular to, what is the vector perpendicular to plane AB and plane BC and plane AC? So you can say that the normal to the plane or A cross B, right? It is parallel, and B cross C, and this is also parallel, and C cross A. Well, these are all normal to the plane ABC. Okay. These three are normal to the plane ABC, right? These three normal to plane, plane of A bar, B bar, C bar. All right. So here you see that box of A, B, C. Okay, there are parallel vectors, so I'll apply that. I'll apply that. This is equal to, there are parallel vectors. So the given expression is equal to, right? Given expression implies, given expression or given equation implies, see A cross B, this is modulus of A cross B into modulus of B cross C. I am applying the dot product of two vectors. Anyway, they are all parallel. So theta equal to 0. So cos 0. Right. Plus. For the other one, modulus of B cross C uh, into modulus of C cross A. It is a very beautiful question. Plus modulus of C cross A into modulus of A cross B. After having so much experience, still I am struggling to get a good idea to solve this question. Right. What is that? This you apply. Assume that angle between A bar and B bar, okay, equal to B bar and C bar, equal to C bar and A bar, equal to some theta. Right? Such that angles between any two of them is same. That is given. So I'll apply that. Here this implies mod A into mod B into sine theta. Isn't it? Mod B into mod C into sine theta. I'll apply that BC sine theta. This is CA sine theta plus AC sine theta into AB sine theta. This is equal to 168. I was thinking I can solve using the previous result. Maybe we can solve it, but it's too lengthy. Now here you see that the product of their magnitudes is 14. The product of magnitudes is 14. So given that product A, B, C is equal to 14. All right. I'll substitute here A, B, I'll take C, right? So this is 14, B is repeated and sine square theta plus 14, here C is repeated, C sine square theta, and next 14, A sine square theta, isn't it? This is equal to 168. So we got that. I am taking sine square theta common. And after that, I will get that A plus B plus C. And on cancelling with 14, other side you will get 14 ones 14 and 14 twos. Now how to find out theta? How to find out theta? Question is not at over. All right. So you need to remember certain things in the right time. That box of A, B, C whole square. This is equal to A square, B square, C square into 1 minus cos theta whole square into 2 cos theta plus 1. Okay. You please visit that scalar triple product. This is equal to 0 implies theta is equal to 2 pi by 3. Theta is equal to 2 pi by 3. So hence we got that this implies sine of 2 pi by 3 is root 3 by 2. So therefore this is 3 by 4. Sorry, this is 3 by 4 into A bar A plus B plus C, sum of the magnitudes is equal to 12, and this is 3 3's cancel, 3 4's cancel. You will get answer 16. What is such a novel question? Well, I am going to prove another a very, very important result. That is cross product of cross product, right? Cross product of two vectors, cross product of two vectors. Well, so here you see that how do we find out A cross B cross C cross D? How do we find out A cross B cross C cross D? See, this is the case. This vector may lie in the plane of A bar B bar, may lie in the plane of A bar B bar, or it may lie in the plane of C bar D bar. So you can write it is as a linear combination of A, B, C, or as a linear combination of C bar and D bar. In either ways, you can write. Well, so how to do this? You see that A, okay, A cross B dot D for test. So that is box A, B, C, box A, B, D into C bar minus box A, B, C into D bar. That is in the plane of that. Okay. So it can lie in the plane of AB or in the plane of CD. In the plane of CD. How to prove it? How to prove it? Okay. Here you see that you take that something like let E bar is equal to A cross B. E bar is equal to, okay, A cross B. Assume. Then LHS is equal to E bar cross C bar cross D bar. Now we will apply that triple product E bar dot C cross D, okay, minus, right, E bar dot D bar. Sorry. This is E bar dot D bar. E bar dot D bar into C bar minus E bar dot C bar into D bar vector. All right. So this is equal to, what is meant by E dot D? E dot D is nothing but E dot AB, A cross B, E dot A cross B. So E bar dot A cross B. All right. Into C bar vector. Good. Minus E bar dot again A cross B. Okay. A cross B dot C. Just a moment. I'll rewrite that phrase. This is equal to, this is equal to E is nothing but A cross B dot D bar whole into C bar vector minus wherever E bar is there, you put A cross B dot C into D bar This is equal to nothing but a box of A bar, B bar, D bar into C bar minus box of A bar, B bar into D bar vector. So I wrote in the plane of C bar and D bar. I wrote in the plane of B bar and D bar. Similarly, you can take the other vector as a E bar. Similarly, you can take other vector in the plane. Right. Okay. Now, how do we prove that box of A cross B, B cross C, and C cross D? This is a very, very important concept. Box of A cross B, B cross C, C cross A is equal to box ABC whole square. To prove this, we have to use the above concept. To prove this, you have to use the above concept. Well, so assume that this is alpha bar vector and this is beta bar vector and this is gamma bar vector. So what is box of alpha bar, beta bar, gamma bar? Even though I have given the proof there, but still I would like to explain on my own. So this is equal to, you have to write that alpha bar, okay, dot, alpha bar dot, beta bar cross gamma bar. Well, so what is this beta bar cross gamma bar? Alpha bar dot, beta is nothing but B bar cross C bar. Well, cross gamma is nothing but C bar cross A bar. Just now we have proved that cross product of vectors. Well, here you see that now you can write this vector in the plane of B bar C bar, okay, or in the plane of C bar A bar. In whichever you want to like, you can write. So this is equal to, you take that for test B cross C dot A, B cross C dot A. So this is equal to alpha bar dot B cross C dot A is nothing but box of BCA into C bar vector minus box of B cross C dot C bar. B cross C dot C bar, that is box of BC bar C bar into A bar. Anyway, that becomes 0 vector. Right? Anyway, B cross C is perpendicular to C bar vector. Okay. Here C bar are collinear vectors, so this value becomes 0. So this nothing but, what is alpha bar? Alpha bar is nothing but A bar cross B bar dot C bar, and you bring out this box BCA outside into box of BCA. Box of BCA is same as of box of ABC. So therefore, this is nothing but box of ABC, box of ABC into box of ABC. This is very, very important to find volume of parallel pipe formed by A cross B, B cross C, and C cross A. If possible, I'll keep that example. And we are reaching at last that if A bar, B bar, C bar are non-coplanar vectors such that R bar is equal to X A bar plus Y B bar plus Z C bar, then we can have that Z is equal to box RAB by box ABC. Okay, that's equal to box ABR by box ABC. Y is equal to box of RCA by box ABC. All right. Nothing but in numerator R is moving. R is changing its position. But whereas denominator box ABC is same. This is nothing but a Cramer's rule. This is nothing but Cramer's rule. It is very easy to prove it. It is very easy to prove it. This is the vector, right? So you take that R bar dot A cross B. A cross B. Then we get that x into a bar dot a cross b. Anyway, they are perpendicular. Plus y into b bar dot a cross b. Anyway, they are perpendicular. Plus z into c bar dot a cross b. So on LHS, you will get box of R bar, A bar, B bar. Whereas on RHS, first two are 0. So the third one is nothing but Z into box of CAB. Box of CAB. That box of CAB is equal to box of ABC. So therefore, Z is equal to, I can write that box of A bar, B bar, R bar by box of A, B, C. That's it. Similarly, you take dot B cross C. Similarly, you take dot B cross C. Then you can find X and Y. Under the same expression that if A bar, B bar, C bar are non-coplanar, then A cross B, B cross C, C cross A are also non-coplanar vectors, right? So here I am going to write that statement. If A bar, B bar, C bar are non-coplanar, are non-coplanar, are non-coplanar, then any vector R bar, any vector R bar, any vector R bar is given by that R bar is equal to XA bar plus YB bar plus ZC bar. Any vector can be represented as linear combination of these non-coplanar vectors, or X into A cross B plus Y into B cross C plus Z into C cross A. If A, B, C are non-coplanar, then A cross B, B cross C, C cross A are also non-coplanar vectors. ABC is box ABC not equal to 0. So therefore, this box of A cross B, B cross C, C cross A is equal to box ABC whole square is also not equal to 0. Well, so this is the vector equation. You can say this is the vector equation. X into A cross B, Y into B cross C, Z into C cross A. Now you take dot A both sides. Take dot A both sides. Take R bar dot A bar is equal to, here A cross B dot A is 0 because they are perpendicular. And C cross A dot A is also 0 because they are perpendicular. Now Y into B cross C dot A is left. This is nothing but box BCA. Box BCA is nothing but box ABC. So therefore, we got that Y is equal to R bar dot A bar by box ABC. Similarly, you will get Z and X also. Well, I will give one example how to use that box ABC whole square. Here is a question. Volume of parallel pipe formed by A bar, B bar, C bar is given as a 2 cubic units. Then volume of parallel pipe formed by 2 into A cross B, 3 into B cross C, and 4 into C cross A. Well, suppose volume of parallel pipe is equal to V. So V is equal to, this is box of A bar, B bar, C bar. This is volume of parallel pipe. Volume of parallel pipe. All right. Okay. Now, V1 is equal to 2 into A bar cross B bar, box of 3 into B bar cross C bar, 4 into C bar cross A bar. This is the volume of new parallel pipe. Volume of new parallel pipe. New parallel pipe. Nice. Okay. So therefore, V1 is equal to V1 is equal. You can bring out these scalars 2, 3, 4 out of the box. Okay. So you can write 2 into 3 into 4. And the box of this is A bar cross B bar, B bar cross C bar, C bar cross A bar. Just now we have proved that this is equal to box ABC whole square. So this is equal to 24 into box of A bar, B bar, C bar whole square. This is nothing but 24 into 4, that's equal to 96 cubic units. So in that way, we can solve many questions. I'll upload some more problems on vector triple product and scalar triple product exclusively. Thank you. Keep watching my channel and enrich your knowledge.